I'm going to discuss with you uh, matrices for angular momentum matrices for J plus, J minus, Jx and Jy. So we have to derive Jx and Jy, J minus and so before entering this topic, I want to tell you one important information about this J plus and J minus eigenvalue. You want to know the exactly how this J plus and J minus eigenvalues like we know already J square is equal to H cross square J into J plus 1. We already derived that thing. So J plus J minus these eigenvalues came from the Krishna-Reichardt theorem or vector coupled theorem. So I didn't discuss till now that theorem. So maybe in the next class I'm going to discuss the theorem. So right now, just you just remember these eigenvalues. If you apply, for example, you know already J square. In case if you apply J square on this quantum state, so then we can get H cross square J into J plus. These are the eigenvalues, and the remaining this thing is the eigenfunction of the system. Okay, so like that, if you apply J minus on the state, the psi m state, you can get this eigenvalue root of, just remember this, the root of J into J plus 1 minus m into m plus 1. So into H cross, this H cross is there outside the loop. Okay, these are the eigen values of, remember here, J plus we are applying. So this J plus is increased this m state by H cross, it means plus 1. It is better to use H cross is equal to 1 for avoiding confusion. Okay, then we can get the correct answer. So in case if you apply J um, plus on this quantum state, J plus means on this J plus will not affect the this J state, and this M state will increase by 1 unit. So which is why I'm increasing the M state, okay, M state plus 1 unit. These are the eigen values of J plus operator. So like that, J minus also there. If you apply J minus on this wave function, then we can get J minus, right? Replacing is right. J minus, it will decrease once. Okay, then eigenvalues of this J minus, J into J plus 1 minus M into M minus 1 to H cross. Okay, so this is equation number 1. This is equation number 2. So here I'm going to multiply equation number 1 by equation number 1 by bra vector. This bra vector J prime and M prime. Okay, so after applying this bra vector, sorry, after multiplying bra vector in equation number 1, so I got this equation J plus, this is J, this is M, that's equal to H cross root of J into J plus 1 minus M into M plus 1. J comma M, just famous bra. Okay, J prime M prime into J M plus 1. Okay, we need to write this notation in terms of conical delta form. Then we can understand the notation value. So the next step is J prime M prime into J plus J into M equal to H cross root of j into j plus 1 minus m into m plus. Okay. So this notation I am going to write like this: delta delta j into j prime delta. For my convenience, I'm using m prime here and m plus 1. Okay. So this is from this equation, you can find easily what are the eigenvalues of, I mean, matrix representations of j plus operator on given quantum. So by using this equation, you can easily find out the matrix representation of the given quantum. So many uses are there. J plus operator. Okay, let us try to explain the j plus and j minus. We know the j value and value, right? It's already we already discussed what is a j and what is m in previous class. First class matrix representation of operators, j square jz. So j is equal to 0. One is there. Here is just wait. I'll show you. This j what is m value. Here already there. See here. So j is equal to 0, 1 by 2, 1, 3 by 2, and so on. M is equal to minus j2 plus. Okay. Okay. Hmm. Sorry for the interruption. Okay. This is 1 divided by 2, comma 1, and so on is there. If you know the j value, m value we can find easily. M is equal to minus j2 minus j2 plus j. So now you can easily find, for example, if j is equal to 0, if j is equal to 0, what is m value? M is equal to 0. J is equal to 1 divided by 2. What is m value? M is equal to plus or minus 1 divided. J is equal to 1. So m equal to 1 comma 0 minus 1. In between minus 1 and plus 1, 0 state also there. So by using these conditions, I'm going to write the matrix form. Okay. First, it is better to write here that equation again. What we written in so j prime m prime j plus j into m equal to h cross root of j into j plus 1 minus m into m plus 1. So here the canonical delta function is j prime m comma m plus 1. So then here I'm making this matrix form. Get vectors, right? Get vector, I'm going to column vectors. These vectors column vectors. Okay, these get vectors. These are the bra vectors. So don't confuse these notations. These are the bra vectors. Okay, for your convenience, I'm going to use this get vector. These are the get vectors. These are the bra vector. We want to multiply the get vector and bra vector, then we can get j plus in between j plus. Okay. So here I'm going to make table. Yeah, it is enough for me. So we already discussed if j is equal to 0, how many m values are there? M is equal to 0. Okay. j is equal to 1 divided by 2. How many m values are there? Two values are. One is plus 1 divided by 2. Another one is minus 1 divided by. The final one is a if j is equal to 1. How many m values are there? 1, 0, minus 1. So similarly, you can write here also same situation here. So these are the j prime values. J is equal to 0, m is equal to 0. Okay. J is equal to 1 divided by 2, 1 divided by 2. M values plus 1 divided by 2 minus 1 divided by 2. So j is equal to 1. Get 3 values, right? 1, 0, minus 1. Okay, that's good. So now it is time to apply our equation. So we already discussed. Again, I'm going to repeat this thing. How we can multiply these values, j and j prime values, like matrix multiplication. So like the matrix multiplication is a similar process, but it's quite interesting. First, we need to check this Dirac delta function, which is, for example, this Dirac delta function. First, you need to check this j and j prime value. If j and j prime value are equal, which means the same state, then this Dirac delta function is the normalization condition, right? So we will discuss this one, j prime, right? So for example, if 1, what is the condition? J is equal to j prime. 0, j not equal to j prime, right? This is the condition. So for example, here j is equal to 0. Remember here, j is equal to 0 means this is ground state. This equation is not going to 0. Okay, when j prime is equal to 0, then this state is got 1. So if it is goes to normalization 1, then you need to check other delta function. So then only this matrix values will generate. So now what is m prime value? See, m prime value 0. Okay, m prime value 0. What is m value? M value 0. 0 plus 1. So this is 0, 1 state, which means different states are there, psi and pi. It goes to the 0. So which is why this entire Dirac delta function is going to 0. Then entire equation becomes 0. Then I got answer is 0. Next, I'm going to multiply. First, I'm going to multiply these things. Okay. Into this column, all the columns. Then I can write here. Okay. Values. So then j is equal to 0 here. J is equal to 1 is there. Okay. First, you need to check this one. If it is normalized, then only you can check this one. This one also normalized, then you can put the given values here. Then you can get the values. So that is the procedure. So here the 0, this one divided by total entire equation is become the 0. Entire equation becomes to the 0, right? Therefore, here this entire equation becomes to the 0. Then this is 0, this is 1. J is equal to 0, j is equal to 1, right? So j is equal to 0, j is equal to 1 means you can get 0 here. Next, here 1 by 2 is there, j value, sorry, j prime value 0 is there. What is that mean? This one is 0. Then this is the main. Here j is equal to 1 divided by 2. J prime also 1 divided by 2 is. Okay, here I'm going to write this Dirac delta function first. So it is better to write here. Just wait. I can show you here. Okay. See, here j is equal to 1 divided by 2. J prime is equal to 1 divided by 2. So this will become a normalized 1. Okay. j prime equal to 1. J is equal to 1, first condition. And what is m value? What is m prime? M value equal to 1 divided by 2, and m prime value is equal to 1 divided by 2. See, m value 1 divided by 2, m prime value plus 1 divided by 2. Listen here also, see, 1 divided by, be careful here. Here m plus 1 is there, okay, which is why you need to be very careful here. M equal to 1 divided by 2 plus 1. Now you can check the value. So this one is 1, okay. Then I want to check this one. This is 1 divided by, this is 3 divided by 2. One state, this is 1 divided by 2, 1, 3 divided by different states, right? Then it is becomes 0. Then the entire equation goes to the 0. This is 2 by 2 matrix, by the way. So then I can write here to like a 2 by 2 matrix. First term I got 0. Next, similar thing I'm going to apply. Oh, sorry. Okay. This I want. This last thing. Okay. Now we can check. J is equal to, what is J value? J is equal to, second condition. Oh, J prime is equal to 1 divided by 2. J is equal to 1 divided by 2, right? And what is m value? M value, m value equal to, oh, m value equal to 1 divided by 2. M prime is equal to minus 1 divided by 2. Then we can check here, 1 divided by 2, 1 divided by 2. This one is 1, and this one is m prime is equal to minus 1 divided by 2. Sorry, here the m, this is m, this is m. Okay, to be here, 1 divided by 2 m, and m prime equal to, and this is 1 divided by 2, minus 1 divided by 2 plus 1. Okay, right. This one is 1 divided by 2. This one become 1 divided, same state 1. So be careful. J prime is equal to 1 divided by 2. J is equal to 1 divided by 2. M is equal to minus 1 divided by m equal to minus 1 divided by. So if you try to apply here, J is equal to, what is J value here? Then these two conditions become one normalized. Then we want to use the M and J value. Then we can get here some coefficients. Okay. What is J value? 1 divided by 2. What is M value? Minus 1 divided by. If you try to use here, J is equal to 1 divided by 2 into 1 divided by 2 plus 1. And here minus 2 minus plus 1 divided by 2, and here minus 1 divided by 2 plus 1. Okay. Then you can get 1 root 1 here. This one is 1 divided by 2, right? 1 divided by 2, 1 divided by 4 is 3 divided by 4. So 4 by 4, root 4 by 4, that is equal to 1. 1. Okay. So here I completely done, did two things. One is this one, and this one and this one. Next, I want to use this thing. Okay. Okay, two different state. J also same, two different state. Here the equal to, this one is minus 1 divided by 2. J prime. Okay. So minus 1 divided by 2. This is plus 1 divided by 2. It will goes to 0. Then you can check all the values, right? And similar thing, this is minus 1 divided by 2, minus 1 divided will never equal to 0. So then it is also 0. Then the final condition, J is equal to 1 divided by 2, J is equal to 1 divided by 2. This is already 0. Next. So first condition is 0, this condition is 0 because the J values are different, J prime are different. This final thing, we can get 3 by 3 matrix. We try to check this thing. Okay, similar procedure. So here I want to check the first thing, then we can go for the remaining thing. Okay. During writing, sometimes I did some mistake. Please identify that. This plus is there, right? Already. Okay, right. Um, okay. Next condition, right? See here the j prime is equal to 1. J is equal to 1. So this condition is become a normalized. J is equal to 1. J prime is equal to 1. Okay. Then I want to check this condition. So what is j value? What is so j prime is equal to, sorry, m prime is equal to 1 in first case, m equal to 1. So in that case, if I put here m and here 1, already 1 is there. This is 1 comma 2. So which means 1 and 2 state. This is 0. This term going to the 0. Then entire equation goes to the 0. Then I can get here the 0. Okay. Next. If you try to use what is j value? This is the same value. Next I'm going to use the m and m prime values. Here the m value 0, m value 0, m prime value is 1. Okay, m prime value is 1. M prime values are 1, right? So therefore, 1, this one is 0 and 1 is there. Then I can got here the 1 if the normalization condition is exist. Just wait, I'm going to tell you clearly this thing, because we need here we can get the answer, right? This one is 1, this one is 1. What is m value? 1. What is m prime value? 1. M value 0 plus 1. See here, this 1. Okay, this is 0. So 0 is equal to m, right? M0, m prime is equal to 1. So this condition, Dirac delta condition, goes to the 1 and 1 state. This is normalized state 1. Then I got here 1. Then only we can try to use j and m, not j prime and m prime values. Okay, this is j, this condition only. Right now, this is m. Okay, if we try to use here 1, 1, this is 0. What you get here? Root 2. Okay, please remember here I'm not using h cross. Okay, in case if you want to use any h cross here, then you can use here h cross. Here also h cross. Okay, this is root 2. So like that, you can check all the conditions. You may get these things easily. In case if you can't get any matrix, then try to comment below, and I can show you the proof. This is root 2, and these are all things are 0 because 1 minus matrix never exists. So this is the j plus. And in a similar way, is if you try to produce the j minus, it's very very important. Going to draw this j minus operator very quickly. So, similarly, j prime, m prime. So if you apply j minus operator on this state, this energy state, then you can get the h cross root of j into j plus 1 minus m into m minus 1. So directly I'm writing here the formula. So you already know how to derive this one. So j plus, then I'm going to write the direct formula here, and these are the j prime, m prime values. Then I'm going to make it table. So in case if you calculate j prime, m prime values, then only you can get the jx and mx values also. Okay, this is a very very important topic. Yeah, that is. Why I am writing each and every matrix. I want this j minus and j plus operators, because I want to calculate j plus and j minus, these things. This 0, this is 0. Same thing, 1 divided by 2 here. Here this one is plus 1 divided by 2. This one is minus 1 divided by 2. Please write down. This is 1. This is 1. This is 0. This is minus 1. Okay. In the similar way, you can write here this one is 0. This one is 0. This is 1 divided by 2. And this is the This is plus 1 divided by 2. This is minus 1 divided by 2. Then final this is 1. Then you can get three things. 1, 0, minus 1. So just if you try to apply these things, then you can get here 0, here 0, 0, and here 0. This is 0, 0, 1, 0. Okay. So be careful when you multiply j and j prime. Okay. These are the j values. We already write these j values. Is need to worry. Is the 0, 0, 0, root 2, 0. Similarly, opposite thing. Okay. Simply, if you remember one thing, then automatically you can write down this thing. Okay. It's time to find out j plus and sorry jx and j uh, y values. Okay. Those are very, very important. Jx and jy values. Okay? So, for example, here I am taking the j plus terms first. J for j is equal to 1 divided by 2. J plus terms is very important. H cross. I didn't use H cross in the above matrices. Just try to use H cross. J is equal to 1. Then we can get j plus is equal to H cross 0, root 2, 0. Here 0, 0. This one is root 2. Remaining 0, 0. Next 4, 4. J is equal to 1 divided by 2. J minus matrix. These are the exact things questions raised by the JSR and GATE exam. Just a exam also. So maybe after couple of class I'm going to take the CSI previous sections class. So how to solve angular momentum problems quickly. Zero. Okay. These are the matrices we find in above the multiple matrix. Okay. Now it is time to find jx value. What is jx? How we can find jx value? We know j. What is j plus rising operator? Jx plus I jy, right? What is j minus jx minus I jy? We add these things, then you can get easily j plus j minus divided by 2. This is jx matrix. You don't want to try different type of x element and eigenvalues. You try to combine j plus and j minus, then you can get answer easily. So combine j plus, for example. So here I'm going to combine both j is equal to 1 matrices. So this is already there, which means this one and this one. Then 1 by 2 is there already. H cross is there. You better to write H cross is equal to 1. And okay. And then you can avoid some confusions. This is J plus, right? What is J plus? Okay, quite opposite. 0, root 2, 0, 0, 0, root 2, 0, 0, 0. Plus 0, 0, 0. This is root 2, 0, 0, 0, root 2, 0. So this is the answer. What is Jx for j is equal to 1? We try to find jx value. J is equal to 1 divided by 2. Then you can add here 0, root 2, 0. This is root 2, 0, root 2, 0, root 2, 0. The answer. This is a Jx matrix for j is equal to 1 condition. is equal to 1 condition. And so in case we want exact thing, use h cross also. Here we can get h cross, right? Then I'm going to write this thing better way. For j is equal to 1. So this is the answer exact. H cross divided by, uh, for example, if you try to common root 2 outside the matrix, then we can get a numerator root 2, denominator 2, right? Then we can write this thing like this. Root 2, right? 2, we can write root 2, root 2. Here the numerator uh, root 2 is there. Then we can get answer this 0, 1, 0, okay? 1, 0, 1, 0, 1, 0. Remember one thing. In case if you use H cross, you can use entire matrix H cross. In case if you can't use H cross, then you can put H cross equal to 1 and you can use in the final answer. Next. Uh, for J equal to 1 divided by 2, Jx matrix. So if you try to add these things, then you can get this answer 1, 0. Okay. So here I'm going to write this thing. So Jx equal to J plus J minus, right? This is 1 divided by 2 is there already here. Then J plus for half 1 0 0 0 and plus 0 0 1 0. Okay, then you can add this. Okay. Next one, important one. Jy x plus it. Jy is a formula 1 divided by 2i. Okay, into j plus minus j minus. I'm going to write only for j1. Okay, for j is equal to 1. So formula this one j by it is 1 divided by 2i. Okay, into the j plus is equal to root of 0 root 2 0 0 0 root 2. J is equal to 1. We already know these things. Then minus quite opposite thing here 0 0 0 root 2 0 0 0 root 2 0. So therefore 1 divided by 2i is subtract this thing 0 root 2 0. Remember here minus root 2 0 here root 2 0 here minus root 2. So I'm going to write root 2 outside the box 2i. Then this is the answer 0 1 0 minus 1 0 1 0 minus 1 0. So this is jy. Yes, if we try to simplify, we can write like this 1 divided by root 2i. Okay, you can write here root 2. So we can write like this, or I'll show you another form. In some textbooks, I observed jy equal to 1 divided by root 2. Both are correct. And explain these things. Okay, this is also correct. There is nothing wrong in that. Okay, both are correct. This is also correct. This is also, I'll show you this proof how we can get here. Okay, so here the portion is there, right? Then you can try to read this thing and this here, this portion from here, not here. Okay, so this portion is there, right? From here to I'm going to, this is root 2 already. Root 2 denominator root 2 and root 2 is there. See, I'm going to multiply I here and I here. Here already I is there, right? So this is I square. Answer is 0 1 0 minus 1 0 1 0 1 0 is there, right? So this is I square. This is this entire thing is minus. Then you try to multiply minus I. bracket. This is 1 divided by root 2. 0 minus I 0 I 0 minus I 0 I 0. So this is the answer. Both are correct. Don't worry. So both are correct. So similarly, you can write J is equal to 1 divided by. These are the uh, angular momentum matrices. Here we already discussed everything. One is the first we discussed J is equal to in J square, Jz, J plus, J minus, Jx, comma, Jy. These are very, very important angular momentum matrices. In case if you get any doubt, just please comment below. Then I try to reply